Hello, this is Dean Palmer, and I will be going over scheduling talent using constraint programming. Problem: in this problem, they are trying to minimize idle time for each actor so that they can just come in on the first day and leave as soon as they're done all their scenes so that the company can pay the minimum amount to the actor on the set of the days they are not in scenes. In simple terms, we do not want them to come in and do one scene and then wait for a long time to do their last scene. I'm going to go into this by starting with the data file on this. So we have actors. We have 6 actors that are real life actors. We have Johnny Depp, Harrison Ford, Brad Pitt, and a couple other pretty famous actors. So each actor has their different pay rates. These aren't accurate for the actual pay rates of what the actors would have, but we have $2,000, and that would be for Johnny Depp, $1,500 for Harrison Ford, and so on going down the line. We have a minimum expenditure because we don't want to not spend a lot of money and not have quality actors, or have a bunch of capital and not spend it, because then that will look bad for the film. They'll take away some of that money. And then we have a maximum budget, obviously, so that we don't overspend. For scenes, which is 10, so we have 10 scenes down here. Each of them have different durations, which is kind of like a penalty. So this one has a penalty of 2, 4, 1. This goes with each of the 10 scenes, so there's 10 of these. Each scene will take a full day, so just have that mindset in mind. It'll help you understand it. And then we have actors. We have 6 actors going down, and 1 stands for they're in the scene, and 0 stands for they're out of the scene. Now what we want is, per se, all the 1s up front and then all the 0s in the back, or all the 0s up front and all the 1s in the back. We kind of just want to bunch them, but we can't do that without bunching other ones, and bunching anything will affect every single actor. So we're trying to minimize these 0s being in the middle, because those are just days that the actor is just waiting around doing nothing, but still getting paid that extreme amount of money if depending on who they are. But in any case, it is a lot of money. So we'll go to the module. Now this is using CP, constraint programming. Right off the bat, we have bringing in our strings and all of our variables, our string actor from the data file with those actors' names. Then we have our budget and our min expenditure, actor pay, number of scenes, all bringing in from the data file. Then we go down to our decision variables. Now, the decision variable is where to put the scenes, also where to put the slots, which I'll try to explain in a second. It's pretty complicated. So right down here we go to the slots. So the first slot would be, this tries to gather all the minimums together, and that would be the best case scenario for every slot. And this one tries to gather all the maximums together, and that would be the worst case scenario for every slot. Then we go down here and we'll see that it tries to take all those first slots and say that, hey, there's no way that it will be less than those first slots, but there's no way that it should be as great as those last slots. That would be our worst case scenarios. So all that gets multiplied by scene duration, which were those numbers going from 1 through probably about 4 or 5 back in the data file. Yeah, so we have our smallest one being a 1 and our largest duration being a 7. So back here we have our final representation of the global cost, actors pay times how long the actor has to wait, which was calculated in this one above. And then I tried to get to display the individual actor wait times, but that display function did not seem to work. So then we have the minimize objective function here, minimize idle cost. So we have it putting that output in the inverse scene slot. And then we also have the minimum expenditure. We want it to be the idle cost to be in between the minimum expenditure and the maximum, which would be the budget. And I also want it to have at least 2 wait days, so at less than or equal to 3, so that each actor isn't working too hard and doesn't have no breaks, because then you won't get good acting. And then we also have that no actor can work for 7 days. Now we'll just go ahead and run this. So we'll go over here and right click, run configurations, run, then default run configuration. It takes about 2 seconds for that to run, and then we can go to solution, and we see our solution that it costs $50,000 400 for the total objective function, and then we can see every scene and which one was scheduled first. So scene 8 was scheduled first, then scene 3, then scene 7, then scene 2, and that is trying to minimize how many zeros and ones we have in certain places here. So also, one thing we can do is when we go over to the idle cost, it will show us that there and how that was calculated. And we go over to actor wait time, we can see how much each individual actor waited. So we have 5, 6, 3, 3, 8, 4. Here's a great chart showing you that Johnny Depp ended up working not working 5 days that he was on scene for, and that cost the company $10,000. Harrison Ford worked 6 days and cost the company $9,000, and so on. And you can go here and you can see exactly who was costing the most money and maybe to replace that person if necessary. I was able to complete while doing this project my scope of customization. I was able to take the number of scenes from 9 to 10. I was able to replace the number of actors from 5 to 6. I was able to make each actor a string variable with a real name and a real pay rate. I was able to give at least actors 2 days break on a 10-scene movie, and I was able to make actors not able to have exactly 7 days off. I was able to make a minimum and maximum spending budget for the film. The attempts that I made, I tried to use Turple to call on individual actors to make constraints for those individual actors to not work certain scenes or not work certain days or not work with certain other actors. I tried to display each individual actor's name in the Windows solution. I tried to make an extra decision variable of each actor's pay to move around and pay rates to make the film cheaper. As you can see in my code that I have all these commented out. What I learned from this? I learned from looking at examples, going through each piece of code slowly and changing it around can really be helpful to get a good understanding of how that code works and you can manipulate it. I learned that IBM offers multiple different methods to complete these tasks and answer questions, and if you look long and hard enough, you can find your answers to pretty much any question. I learned that IBM can be a great tool to settle complex scheduling problems very quickly.